Number 7, in the standard XY coordinate plane below, 3 of the vertices of a rectangle are shown. Which of the following is the fourth vertex of the rectangle? On this one, since it's a rectangle, we know that the opposite sides are going to be parallel, and that each time we go from vertex to vertex, we're creating a right angle. So these are a little hard to read, but that's the point -1, 1, 2, 1, and 6, -5. So if I can connect those, I can kind of give a ballpark area. I know my other vertex has to be here to make a rectangle. So if I'd had choices, it might be easy to kind of eliminate and find those. The way I'm going to find this point down here is to look at how I went from this point to this point. And then I can do the opposite of it from this point to get our new point. So what I mean by that is to get from this point to this point, I have to go up how many units? Well, on the y, I'm going from a -1 to a +1. So that means I went up 2 units. I had to go to the right, which is the x-coordinate, -1 to +2. So that means I went over 1, 2, 3 units. So I want to do the opposite of that to go from this point to my new point here. This point is 6, -5. So if I don't go right 3, I'm going to go left 3. So if I go left 3, I had a 6 as my x, but I'm going left 3. So now this is going to have a 3 as my x. So I know my x-coordinate is a 3. Instead of going up 2, I'm going to go down 2. My y was a -5, so when I go down 2, I'm at a -7. So this is where my new point is, and I can kind of visualize that making that rectangle. So again, I just did the opposite of this to get to this point right here.